All right, welcome back to Mr. P. Alps with Algebra 2. This is Unit 4, Topic 1, SLT2. We're going to start introducing the idea of combining functions. And in this warm-up, which we are going to basically just do what we're doing in this topic, which is add and multiply two different functions together. So in the last video, if you watched it, we talked about all the different functions you have done in Algebra 1 and in Algebra 2 so far. Well, in this case, we have two functions that have already been graphed for you. The red one is x, which is a linear function, and the blue one is a trigonometric function, which happens to be sine of x in this case. And what we're going to do is we're going to add these two together. So what you do is you add those 2 points together. So the red point, so if you go to an x of 1, let's say x is 0. Well, both points are right here, and 0 plus 0 is 0. So now if I go to 1, I'm going to add the red plus the blue. So 1 plus almost 1 makes almost 2, which is right there. And then I'll do the exact same thing for all the other x values. So I go to this value, so that's about 1, that's about 2. 1 plus 2 makes 3 right there. I'll go to the next one, which is 2. They're both 0, so that's about right there. If I go to the next one, so that's about negative 1 plus 1, 2, 3, 4. Negative 1 plus 4 is about 3. 1, 2, 3. And what I do is I just keep adding. Okay, this one was the wrong one. So that was 0 plus 1, 2, 3. 0 plus 3 is 3. So let me put that in the correct spot because that didn't look right. So this is going to end up looking something like this. And then this way, it's going to end up doing the exact same thing. And I'm going to show you the answers in a couple more slides. But you would do pretty much the same premise for all of these. Now, this one would do kind of the same thing, only it's going to go down like this. And for multiplication, you do the same process. So 0 times 0 is still 0. 1 times 1 is still about 1. This is about 1 times 2 is 2. This is about 0 times anything is 0. This one's negative 1 times 1, 2, 3, 4. Negative 1 times 4 is negative 4. 1, 2, 3, 4. So you end up something like that. So once again, I'm going to show you these answers here in a second. So here they are. So you can see what happens generally. So this is a trigonometric plus a linear ends up doing this. So pretty much it follows the path of the red line, as you should notice. And over here, when it's negative x, actually this should have been going down, but okay, so this ended up being the exact same thing. So this should have been going down, same exact thing, only going down. This one, when it's x times sine of x, what you'll notice in the purple is the answer, and I will highlight that a little bit more so you can see it. So what you'll notice is that the further you go to the sides, and it'll keep getting higher each time you go out. Same thing for this one. So the further you get away from the origin, the higher the function is going to be going. So its amplitude is actually changing. All right, so we're going to look at some more examples here. So what two types of functions do you see? Well, you can, okay, that was supposed to be showed. So I see a linear piece and I also see a trigonometric piece. So when you take those two pieces and you put them together, and the midline happens to be 2x in this case, it ended up looking, and you'd already seen it, looks like this, because it's going in the same fashion of a linear line, and it looks trigonometric. If you just look at it, it's waving just like a trigonometric function. For this time, you see absolute values involved and trigonometric. It's absolute value signs on the outside, so in this case it does not ever go below 0 because in this case it's absolute value, it's always going to stay positive. And it kind of has that trigonometric look to it. It's waving back and forth, but it also has pieces that are in V's. This is a linear and a trigonometric. So anytime linear, trigonometric, so you know that the midline's not going to change. I was trying to draw straight across, but you do know that its amplitude is changing because it's multiplication, and its midline doesn't usually stay the same, but in this case it does because it's going straight across. But you can see that it's clearly doing a trigonometric look to it. It's doing that wavy sort of pattern. This is an exponential being multiplied by a trigonometric, so it's going to be a trigonometric, which is going to be a wave, but it's also going to be curving up. Actually, this is curving down because it's decay, because it's 0.9, it's less than 1. And you remember we did that in the last video, anything between 0 and 1 is always decay. So it's actually decaying. It's kind of hard to see, but it actually is decaying. It's going like this. So if you're going to follow the pattern of it, it's going like that, which is the amplitude, if we touched all the amplitudes, because it was multiplication. We have a quadratic here and a trigonometric. It's going to look like this, and it does kind of take the shape of a quadratic pattern. So that's what you see there. Okay, so basically when we are adding, the midline changes, and when we are multiplying, the amplitude changes. That's the conclusion that we've come to. So is this midline or amplitude, and what two types of functions is it? Well, actually, this one is very hard to tell, but it's looking like it's definitely the amplitude that's changing. So I definitely know that multiplication is involved. What exactly is it combined with a trigonometric? It's kind of hard to tell. I could make a case for the fact that it is exponential if it was like that, if it had like a translation to it, or you could just say it's linear. It's most likely just going to be linear multiplied by a trigonometric. This one I think is pretty clear cut. This one is definitely going up exponentially. The midline is changing this time, not the amplitude. So you notice that the waves still have the exact same height all the way across. Only the middle of the wave is curving up like this. So this is trigonometric, and it's, okay, this one was met, this is addition. This is trigonometric and exponential. A couple more examples. So this looks like square root. Its midline is changing, which means it's addition, and this is trigonometric and square root. Now this one is another tricky one. If you follow the amplitudes, so the amplitude is changing, which means it's multiplication. That's always going to be the case. Keep in mind, if the midline changes, it's always addition. If the amplitude changes, it's always multiplication. It's clearly trigonometric because you can see the curve pattern, but you can clearly see that the amplitudes make a V pattern, which is absolute value. And that's going to be all for this video. And then I'm going to make one more video, which is going to do pretty much the exact same thing as this topic as that we just got to. Thanks again for watching, and have a great day.